All right, we are picking up with Unit 1, Lesson 15, starting with example 5. So in this problem, we're going to be simplifying radical expressions, and we have the sixth root of 16 divided by the third root of 2. So the first thing that we're going to do is we're going to take the 16 and we're going to rewrite it as 2 to some power. And the reason I'm picking 2 is because I see that this is also a 2 down here in the denominator. So hopefully you realize that 16 is 2 to the fourth power. So 16 to the 1/6 is the same as 2 to the fourth to the 1/6. And then remember that we multiply these exponents, so we have 4 times 1/6, which is 4 over 6. And 4 over 6 reduces right here to 2 over 3. So I have 2 to the 2 over 3 power, the 2/3 power, divided by 2 to the 1/3 power. And there is an exponent property that will help you simplify this. And if you look at the poster in class, you'll be able to see which property to use. But basically what you do is you're going to be subtracting these exponents. Whenever you have a fraction, you do the top exponent minus the bottom exponent. So 2/3 minus 1/3 is 1/3. So you can write 2 to the 1/3, or you can write the cube root of 2. And this right here is your final answer. All right, for part B, we have the sixth root of 4x to the fourth power. So this time again, we're going to take 4x to the fourth, and we're raising that to the 1/6 power, changing the sixth root to the 1/6 power. And we're going to rewrite 4 as 2 to the second, and we're going to write x to the fourth as x to the second power to the second power. Remember, 2 times 2, that's how we would have gotten this 4. So we have 2 to the second to the 1/6, and that would be 2 times 1/6. 2 over 6 is 2/6, which is reduced 1/3. And x squared to the 2 times 1/6 power, that's 2 over 6 again, simplifies to 1/3. So this would become, each of these is to the 1/3 power, so we can just do the cube root and then put them both inside the single cube root, 2x squared. And that's our final answer. Okay, for part C, this one probably is a little bit scarier to you. We have y to the 1/2 plus 1 divided by y to the 1/2 minus 1. And I'm pretty sure we're going to be using conjugates on this problem to simplify it. All right, this gets pretty scary and intimidating right here. So what I'm going to do is I'm going to rewrite this problem as the square root of y plus 1 over the square root of y minus 1. I think this problem is a little bit easier to understand if we use square roots instead of the half powers, the fractional exponents. And so remember, whenever you want to get rid of a root in the denominator, we multiply by the conjugate. So they're doing the conjugate of the bottom. The conjugate of root y minus 1 is root y plus 1. So we're going to multiply by root y plus 1 on the bottom. And whatever we do to the bottom, we have to do to the top. So we're also going to multiply by root y plus 1 on the top of this fraction. And from here, we're just going to be foiling. You're going to do the first times the first, the outside terms, the inside terms, and then the last terms, doing that on the top and on the bottom. When you do that, the roots go away. On the bottom, you'll be left with just y minus 1. On the top, you'll be left with y plus 2y to the half power. Remember, that's 2 times the square root of y. So y plus 2 root y plus 1. And you can use either the root symbol for this, or you can use the 1/2 power if you prefer to do that. All right, some check your progress problems. When you have your answer for this, go on and advance to the next slide. And our answer this time is ooh, they don't want to tell us. Maybe they'll tell us here. All right, now the answer is B. Let's check out another one. Simplify the 6th root of 16x squared. When you have your answer, go on and advance to the next slide. Let's see, our answer is letter A this time. And one more check our progress problem. We have x to the 1/2 power, or the square root of x minus 1 over the square root of x plus 1. Remember, you're going to have to use conjugates for this problem. It's going to probably take you a while, so pause the video as long as you need, and when you have your answer, come on back and go to the next slide. Your answer this time is choice A. We're going to summarize the concepts in this lesson real quick. 4 key points. It says an expression with rational exponents is simplified when all of the following conditions are met. First condition, you can't have a negative exponent. Second condition, it has no exponents that are not positive integers in the denominator. The denominator has to have only positive integers. You may not have negative integers as exponents. No negative exponents in the denominator. They don't want negative exponents, period. They don't want negative exponents in the denominator either. Not a complex fraction. That means that you cannot have roots in the denominator. No roots in the denominator. And the last condition is that the index of any radical, any root, is the least number possible. This last condition, it was the focus of example 6 that we just finished working on. So make sure that every time you're trying to simplify something that you follow these 4 conditions. Can't have negative exponents, can't have roots in the denominator, and make sure you simplify the roots as much as you possibly can. Okay, that's the end of Unit 1, Lesson 15, and it's going to be the end of Unit 1 as a whole.